Welcome all. Welcome to this lecture of Object-Oriented Programming 1. Today we'll continue. We'll start with Unit 9. That is Binary I/O, Recursion, and Generics. Okay. Let me show the disclaimer. Then I'll start the session. Okay. So, what is text I/O and binary I/O? So, this chapter deals with input-output. It can be an input-output of text or binary input-output. Okay. So, see, files can be classified as either text or binary files. Okay. And a file can be processed. Means what operations can be done on it? Operations like read, creation, modification, deletion. These kind of operations can be done on a file, right? And using a notepad or something like in an editor, such text editor, you can create a text file, right? But you cannot create binary files. You cannot read binary files using a text editor, right? They are designed to be read by programs. Okay, so you cannot create your own binary file. You type in a notepad and save it as a binary file. No, that's not working out. So example, a Java file, let's say a class file. Okay, a dot class file that would act as a binary file, right? So now Java provides many classes for performing text I/O and binary I/O. Okay, binary input output and text input output. For all this, Java provides many classes. Okay. So the text file is nothing but a sequence of characters. And what is binary file? Binary files is nothing but the sequence of bits. Okay. So, for example, see, decimal integer 199 is stored as a sequence of 3 characters 199 in a text file. Okay. And the same integer is stored as a byte type value C7 in a binary file, because decimal 199 equals hexadecimal C7. Okay, so this is how two values are stored in, one in text type and one another in hexadecimal. Okay. So the advantage of binary files is that they are more efficient to process than text files. They are much more efficient to process than text files. Okay, and Java offers many classes performing, and these input-output operations can be classified as text I/O and binary I/O, and we have classes for both text I/O classes and binary I/O classes offered by Java. So the text data are read using scanner class and written using print writer class. So almost we have seen this thing in unit, right? How we use scanner class to read from a file and how we use print writer class to write onto a file. Okay, and so for example, here we have an input class that contains the method to read data, and then we have an output class that contains the methods to write data. Okay, so if file is there, it is read using input stream. See, now what happens is a file is always read using an input stream in the form of bytes, right? So an input object is created from an input class, and similarly an output object would be created which would write the data into the file using output stream in the form of bytes. Okay. Now what's the difference between both text and binary I/O? That binary I/O does not involve encoding or decoding, and that's why it is more efficient than text I/O. Text I/O involves encoding, text encoding. Okay, so all the files in a computer are stored in the binary format, and encoding and decoding are automatically performed for text I/O. Okay, so it's something like this. See, when a program is performing an IO with, let's say, a storage device, what happens is if it reads the characters, right? If it is reading a characters, then it needs to encode those characters, okay, after reading them. If it is writing, then it needs to decode it. If it's reading, it may need to encode, right? So after encoding these values, it gets converted into simple what? It gets converted into simple 199 string. Okay, this is just a sample. And similarly, if you are using, a byte is read or written, the same byte is in the file. So 199 is represented as this, that is 0xC7 or 11000111. So the same byte is written into the file as it is. So that's why binary IO is much efficient. It does not require this encoding and decoding part. Encoding what? The bytes that are stored to be encoded in the form of text. Okay, that is needed. See, in the end, the disk stores everything in the form of bits only, right? Even if you are storing characters, it stores in the form of bits only. So those bits need to be converted into characters, and the characters need to be converted into bits, right? So encoding, decoding is needed. Okay. Binary AI does not require conversions. Okay, and binary files are independent of the encoding scheme on the host machine and thus are portable. Java programs on any machine can read a binary file created by a Java program. So this is why Java class files are binary files. Okay, why? Because these can be read. Java can be read by any JVM. Okay, and Java class files can run on JVM or any other, on any machine that has JVM. Okay. So see, these are the binary IO classes. It starts with object. We know that object is a superclass of all. And inside, under object, there are two main classes. There is input stream and output stream. So since IO works on streams, we need two classes to represent both kind of streams. Okay. And input stream has further subclasses like file input stream, filter input stream, object input stream. Similarly, output stream has file output stream, filter output stream, and object output stream. And filter input stream has got, data input stream and buffered input stream. Similarly, here we have data output stream and buffered output stream. So this filter input and filter output streams have some advantages over regular streams. Okay. And this input stream is abstract. It's the root class for reading binary data. And output stream, which is also abstract, is the root class for writing binary data. Okay. So if you want to access binary data, you use input stream and output stream classes. Okay. Which are basically abstract, but their subclasses are used. Okay. So say this is the input stream class. It has got method like read, which does what? It reads the next byte of data from the input stream and returns that byte of data in the form of int. Okay, the value byte is returned as an int value in the range 0 to 255. If no byte is available because of the end of the stream, then it will return -1. Okay. Similarly, you have read, and what you can do is you can read into a byte array, right? What do you say? You say read up to B. Okay. What is that B? That's the length of the bytes into the B array from the input stream. And the actual number of bytes, and returns the actual number of bytes read in the form of int. So This does what? This read will read according to this byte size, byte array size, and it will return the number of bytes read from the file. Okay. Similarly, we have read by the byte of int and length int. So what does this do? See, this reads the bytes from the input stream, that is from the file or from the input stream, and stores them in b of plus 1, and so on and on. Okay, so it starts with this offset. Starts with the offset, storing it starts the offset, and the actual number of bytes read is returned is nothing but the -1 at the end of the string. If there is an end of the string, it returns -1, right? If it returns the actual number of, it reads some bytes, then it gives the number of bytes read, and it starts from, it starts storing from offset and up to this length. This many number of length has been read and put into this byte b array, byte array b. Then we can check whether that, available means it returns an estimate of the number of bytes that can be read from the input stream. Okay, so whether there is some data available in the stream or not. Then it will close the input stream and releases any system resources occupied by that, right? Then there is a skips over and discards n bytes of data from this input stream, right? And this number of bytes skipped, there is returned. How many number of bytes skipped? That is returned in the form of this long. Okay. Then we can say mark supported input stream. This mark supported. This does what? It tests whether the input stream supports the mark and reset methods. There are this mark and reset methods, whether that is being supported by the input stream or not. Then you can mark, if it is supported, then marks the current position in the input stream, mark read limit. You can even reset. Okay, reset the position. You can reposition the stream to the position at the time of mark method was last call on this input stream. So mark and reset would be used, mark and reset would be used together, and in order to check whether it supports marking or not, we use this mark support. Okay. So this is an input stream class. Then we have output stream class, which has methods like write and int, right? So it does what? It writes the specified byte to this output stream, and the parameter b is an int value, right? Byte b is returned to the output stream. But this is, this is a byte, basically byte number. Then we have what? Right? A whole byte array. So it writes all bytes in the array b to the output stream. Whole byte array is returned into the output stream. Then we say write byte b and of int and length. So what does it do? It writes from this byte b, starting with this offset, and goes up to the length of plus length -1. That many bytes are returned onto the output stream. Okay. When you say close and flush, you can close the output stream and release any resources and flush this output stream, and it forces any buffered output bytes to be returned out to the stream. Flush is good to use. So that was about input stream and output stream classes. Right now, how we use file input stream and file output stream. So check this out. All the methods in this classes are inherited from input stream and output stream classes only, right? And so java.io.file.not-found exception will occur if we try to create a file input stream with a non-existing file object. If there is a file that does not exist, right, and we try to create it with the file input stream, right, so that will throw a file not found exception. Check this out. This is the input stream, which is abstract, from which this file input stream inherits, and it provides two constructors: file input stream, where you provide a file, and file input stream, where you provide a file name as a string. Okay. So this takes file object as an input. This takes file name as an input. Similarly, we have file output stream. So here also, if file does not exist, so here what does it do? It does not see, it does not throw an exception. If that does not exist, then it creates a new file. Okay, a new file will be created, and if the file already exists, the first two constructors will delete the current content of the file. Okay, so these are the two constructors. File output stream, either you give the file object or the file name. Okay, so it creates what it see it creates the stream from a file object. This creates a stream from the file name. Okay, and to retain the current content and append new data, what shall we do then? Right, so in order to do that, we use uh, last two constructors and pass true to the append parameter. Okay, so these are the last two constructors. Just a minute. Okay, so see, these are the last two constructors. File output stream, file, and append. So you say if append is true, right, then what happens is that the data is appended to the existing file. And here you say instead of file, you got what? You get file name. And again an append, which is boolean, which basically appears if you say true, then it appends the data. So remember, if you are using file output stream, right, if you are using file output stream without boolean, then it overrides the file. So this is the constructors. Okay, and if you are using this file output stream constructors with append, which is a boolean value, then that basically appends the data to the file. Okay, okay. Abhishek is asking how to create a file in Java. No issue, Abhishek, we are just seeing that only. We are seeing those classes which basically deals with creating files and working with files. Okay, so first see all the theory of the classes. Okay, and then you will get to see the program also. Don't worry about that. Okay, so see, in this hierarchy of classes, we saw what are the methods of input stream and output stream classes, which are abstract. Then we saw file input stream and file output stream. Okay, we just saw file input stream and file output stream. Okay, now let's see what is there in data input stream and data output stream. So the data input stream reads bytes from the stream and converts them into appropriate primitive type values or strings. This is very much important. So you directly want to read into values, or you directly want to read string values or something like that, right? Then you basically use what? Then you basically need this data input stream and data output stream. Okay, so it can directly do what? It can directly read the values. So check this out over here. See, data output stream also converts primitive values into bytes. So the reversal is also true. When you are reading, you read the bytes, but you convert it into primitive type values. And we are writing, you write the values, primitive type values into bytes. Okay. So check this out. Here we have this. Here we have what? Here we have this data input stream. right? Which you can see that input stream is there, filter input stream is there, and we have data input stream. See, this notation means that it's a it's a concrete class. This notation means that it's a concrete class. Okay, and and check this out. It implements this data input interface. Okay, this data input stream implements this data input interface, which has methods like read boolean, read byte, read char. Okay, and you can see there are lots of methods available to, to read directly the boolean, byte, char, float, double, int, long, short, even a line as a string, and even UTF values. Okay, read the string in the UTF format. This is the kind of format. Okay, so see, data input stream and data output stream can read the this way. What happens is it reads and writes primitive data type values and strings in machine independent fashion. So it enables us to write data file in one machine and read it on another machine, and has a different operating system, so it does not depend on the system. Okay, uh, so check this out. Here what happens is, uh, it might happen that you are reading from an external file, right? So for reading, what happens? External file, the external file gets read into file input stream, and file input stream gets read into data input stream, right? So this bytes get converted into primitive data. And similarly, when we are writing, you do what? When you are writing, you have data output stream which writes onto the file output stream into external file. So you have primitive type data which gets converted into bytes and then gets written. Okay, just a minute. Okay, let me again continue. So we saw how, see, data input stream is working on top of file input stream. Okay, to write and read the files. Data input stream and data output stream are working on file input stream and file output stream to read and write external files. Then we have buffered input stream and buffered output stream. This buffered input stream and buffered output stream can be used to speed up input and output by reducing the number of disk reads and writes. Okay, so if you are using a buffered input stream, see, if this is a program that reads individual data, then what it can do is the buffered input stream can buffer a block of data, and those blocks of data can be read all together by buffered input stream object. Similarly, when a program is writing something, that can be buffered and all together return as a single block of data. So basically it speeds up input and output. Okay. Then you have object IO. And object IO is object input stream and object output stream classes, which can be used to read or write serializable objects. Yes, serializable objects are the objects that can be stored in some storage. Okay, it can be stored in disk or in database, in a file or somewhere. Okay, it can also be sent over network. So the object input stream has only one constructor with this, which gives it takes an input stream object. Okay, and it implements object stream constants, and it also implements this object input interface where read object method is there, which returns the object type of object itself, object class itself. Okay, and it also has this. It also implements this object output where you can write an object and returns nothing. Okay. Now see, what is serializable? We'll ask now, what is serializable? So serializable is nothing but an interface. Last time we saw interfaces, right? So serializable is an interface. So if you want that the instances of your class can be saved somewhere, onto the disk, then you can implement this serializable interface by your class. Okay. So a serializable object is an instance of the serializable interface, so that the object's class must implement the serializable interface. And this is nothing but a marker interface. You just mark the class to be serializable. That's it. You don't implement any method. Okay. Since it has no methods, you don't need to add additional code in the class that implements serializable. Okay. So, and Java provides a built-in mechanism to automate the process of writing objects. And this process is called as object serialization, which is implemented using object output stream. Okay. So now if you want to write object output stream onto a file, then you can use object output stream and then file output stream, and then write that object to the file. Now there is something called as random access files. Okay. Java provides random access file class, right, to allow data to be read from and returned to any location in the file. Okay, so that is random access. Normally what happens, the file is read as a block, and it starts from starting, and then we go on reading up to the end. Once the end reaches, it returns -1, end of the file. Okay, so but using this random access file, you can read or write to any location, to or from any location. Okay, and all the streams that we have used so far are basically read only or write only streams. Okay, either the file input stream, which is read only, file output stream, which is write only, right? Data input stream, reading only, data output stream, writing only. But this random access files work on the streams which are called as basically say, okay, these are sequential streams. No, these are sequential streams because it reads in a sequence, whereas random access files works on, it works randomly. It does not follow this sequential stream. Okay. So Java provides this class to allow data to be read from and returned to at any locations. And a file that is opened using random access file is also known as random access file itself. And the random access file class implements what data input and data output interfaces are implemented. Okay, and when you are creating a random access file, you can specify one of the two modes, that is read or read write mode. Okay, R means stream is read only, and RW means stream allows both read and write. Okay, so check this out. This is a random access file class. Okay, where we have what random access file constructors are there. Okay, which take the file as an input and the mode for reading or writing, read write, reading writing both, or it takes file name and the mode. Okay, so it creates the random access file stream. Remember, it does not create the file, it creates a stream that accesses the file. Okay, similarly there is a close to close the stream and release the resources, then get file pointer to see where our pointer is currently inside the file. It returns the offset in bytes, okay, from the beginning of the file to where the next read or write can occur. Okay, so see, this get file pointer is very important in order to access. We can get the length, that is the number of bytes in the file. Then we can read that reads a byte of data from this file and it returns -1 if it is at the end of the file. Read whole byte array, it can read into whole byte array up to the byte size. Then it can read byte arrays starting from offset up to the length, and it can seek the position. Okay, when we say seek position, it sets the offset, sorry, it sets the offset in bytes specified in position. Okay, so from the beginning of the stream to where the next read write occurs. So you can, you can seek a particular position and go to that particular position in order to read or write onto that position. Okay, when you have set length, it sets a new length for the file, and you can even skip some bytes, right, over the input, and you can write a byte array into that file. Okay, or you can write from byte array, you start from offset and go up to the length. In that way you can write. Okay, and this implements data input and data output interfaces both. Okay, now the random access files basically consist of a sequence of bytes. Okay, and a special marker called find pointer is positioned at one of these bytes. This, for example, these are the byte sequence of bytes contained inside inside what? Inside the file. Okay, and suppose the file pointer is currently at this location. Okay, so for example, if you read an int value using read int, the JVM reads 4 bytes for the file pointer, because int is represented using 4 bytes. So at this point, when the pointer is over here and you say read int, okay, using the using that reference variable, then these 4 bytes would be read as an integer value, because integer requires 4 bytes to be stored in Java, right? So what happens when you read it? Before read int, your pointer is over here. Once the pointer is read it, it goes from here to here, and the pointer comes over here. Initially it was over here, now it has come over here because it has read this 4 bytes as an integer. So see, this is how we access randomly from the file. Okay, so these are what? These are various classes that we use for text IO. Which classes did we saw today? We saw input stream, output stream, which are basically abstract, but then we also saw file input stream, file output stream, Then we saw from filter input and filter output stream, we saw buffered input stream, buffered output stream, data input stream, data output stream. Okay. So these are some of the classes that we saw today. Okay. And let me show you one of the examples. Let me open up and let us open up into the Visual Studio Code, and then there we'll make one of the programs that deals with. I'll show you one example of buffered input stream. Okay. So we have what over here. Let me make one folder which is unit 10. Inside unit 10 we will make one file. Inside this unit 10 we will make one file, calling it as what? Buffered example 1.java. Here we will use main. Inside this, let me show you buffered reader. Buffered reader basically needs what? Here we say new buffered reader. Before that, let's put this into what? Into package and 10. And here we have buffered reader, new buffered reader. Here we say what? New input stream reader, and inside input stream reader we give what? System.in. Okay, so check this out. This is how we declare buffered reader object. How do we declare it? Like this. Okay, so for this, what is the issue? Issue is you have to import java.io. So we import. Let's import java.io.star. So this gives what? This gives us a new buffered reader object. How? By saying buffered reader br equal to new buffered reader and new input stream reader. See, buffered reader reads an input stream reader object, and input stream reader reads the input stream. So system.in is the input stream which represents what? Which represents the keyboard. Okay. Now we'll say we'll put some value. It's system.out.println. Enter your name. That's what we'll print. Okay. Instead of println, we will print only that's it. Here we can put new line. And now, once we say enter your name, so we need to read it, right? So we need to read it into a string. So we say string name is equal to br, that is buffered reader dot read line. That's it. So it directly reads the whole line. Okay, what is it giving? Add throws declaration. Now see, this read line can throw an exception. So we say add throws declaration. So now you can see this main can throw IO exception. Read line can throw IO exception. So that's why we need, and it's a checked exception. So we need to declare it. And now we will be using what? We'll be just simply displaying it out. We will say system.println welcome plus name. Okay. Very, very simple program. Takes your name, reads your name or asks for your name, okay, and displays it out. That's it. Okay, so it reads whole line. This whole line is read. Okay, when from starting from here up to where you press the enter. Okay, so check this out. Even if I run it like this, I will say 6EC1 class students, and as I enter, check this out. It has read this whole string, and it says welcome 6EC1 class students. You see that? So it reads. It does not read one byte or one element at a time. It reads whole line. Okay, and converts it into a single string. Converts it into a single string. Okay, this is how buffered reader works. Okay, this is till now you might have also you people have also seen the use of scanner, right? In scanner, how do we do? It's a scanner input is equal to new scanner, and here we do what? Here we give. Here also we give the input stream object. In what is this in? You can check this out. This in system.in is where in is the input stream object, right? Which represents the keyboard. This represents what? This in represents the standard keyboard. Okay. So whatever you type can get read through that input stream. So here we have created the scanner object. Okay, and we import it, and then we can say input what? We can say input dot read or next. Here we can say next line or next, which is also string, or next int. Okay, so if we say next, check this out. What happens if we say next? Okay, here also let's name 2, and here we, instead of saying read line, we will say what? Name 2 is equal to input dot next, and then we say welcome name 2. Okay, let me just okay, now let me show the difference also. Let me just first make this as commented, and I'll show the difference between the both. Okay, we need to give a message, right? So here we'll give the message. We'll say enter your name. Okay, enter your name. So here it says, where is it? Okay, it says enter your name. I say 6EC1 class. It says welcome 6EC1 class. But if I again run it and then I say, check this out, I say 6EC1 class. It only reads the 6EC1 part. Okay, it does not read the whole line. You see that? And again, if I run it, it's even if I say 6EC1 and class. So see what happens. Check this out. What did I do? I typed this 6 as differently, put a space and then EC1, put a space and then class. Okay, so there are 2 spaces. So what did it do? It read only the first input. See there? It says welcome 6. So you see the difference between these two? Okay. Now let me again run this and let me show the difference. So here we say enter your name, right? And we say 6EC1 class. It reads the whole line. And again it asks for enter your name and we say 6EC1 class. The same kind of input is given and you can see what's the difference. The same input is given during both the times, and this reads the whole string, whole line, and this reads only one string. Okay. So you can see that if you are saying next, it reads only once. Now if you want to read a whole thing, then you say next line. Okay, you say next line. So this will now read whole line. Okay, so check this out. I again say 6. Here I again say what? 6 EC1 class. It reads whole line. Again it asks for name. We say 6 EC1 class, and it reads whole line. You see that? You see the difference now? It reads whole line. Okay, so that's it for today. Let's end our session over here. Any doubt, please do let me know. Okay, if at all any doubt, please do let me know. We can have an interaction.